Hi, today I'm going to show you how to create a DSS dataset using HEC-DSSVue software package. So this software package is developed by US Army Corps of Engineers. So if you have different types of dataset like time series, if you have paired data like stage, discharge, scarf, and if you have elevation and then corresponding stage or corresponding different data set. So if you have even the constant reservoir level and other data sets, so what you can do, you can even compile them together in a single data set called .dss file. So this DSS means data storage system, and it is even compatible with every ACC software like HEC-HMS, HEC-RAS, and HEC-ResSim, and other softwares developed by US Corps of Engineers. And it is very efficient to store, and it is very effective to import and export dataset. You can directly use those data and you have the access from every software. So that's why if you can generate this dataset and you can even transport it to someone else, and you can even use anywhere, and you can plot, and you can even export the plot, and you can directly use those plots for your report. So this is how it is important. So that's why what you have to do, you have to even download that software first. I'll give you the link in the description below as usual. So you can download for your Windows and then you can install. So since I have already installed that one, so I'm going to show you how to generate the dataset from different types of raw data like .csv and Excel, text, or manual entry. And I'll even download the data directly from the website, and then we'll merge different dataset into one dataset, and I'll show you everything. So let's start from the start menu. If you already installed that one, you'll see that HEC-DSSVue and the version. What you have to do, it is empty, there is nothing. So go to file, and then you'll see two different options, version 6 and version 7. I'm gonna create the dataset using the latest one, the version 7, new version 7, and it's gonna ask you where to save. So I know the directory, I'm gonna give the name as simulated. So first I'm gonna create a DSS file by simulated dataset. Okay, I have the simulated dataset from National Water Model, and then I'll create another observed dataset, and then I'll merge them together. So this is how I'll show you how to do different operation. I'm creating this one, so it created and then it's empty. And if you are familiar with this DSS file, you'll see that it has different paths. So part A, part B, part C, part D, and E. These two parts are dedicated to time range, right? And F, you can even give any description. But usually what we do, part A is for any bigger watershed or the region, and part B is for any river or any specific location, and part C may be the description of the data. If it is rainfall, if it is stream flow, and part D and F, these are the time range and the date range. You can't even change these two. And F is the source. If you have a data set like from any model, you can give the name of the model. And if you know the rainfall, if it is rainfall data set, so give the sources of the rainfall data set like stage 4, stage 3, or if it is from any observation or any simulation or any other product. Okay, so I'll show you that. So at first we can create that. We have the empty data set, we have to populate it with our time series or any data we have. So first go to data entry, and then we'll start with this manual time series. Then we'll also do this operation manual pair data, and then we'll import different types of data set here. So let's start with this manual time series. Okay, so here it is going to give you this option, this part A, part B, and part C, but C is not going to give you part D and F. Okay, and D and E. So here this is going to be my watershed name. It is located in Texas. I can give the name as Texas or Matagorda. This is the name of the station I'm just trying to enter here. It is located within Texas, and the name of the watershed is like Matagorda. And what is the name of the station I have? It is like EDN-T2. Okay, this is the station, or you can give any number. And what is this? This is basically simulated. Okay, so I'm giving this type simulated, and then I don't have any option to enter for D and E. It is gonna be like your time step, the data range. For example, for my case, and by default it is hourly data, and for the F part you can give the name of the model output or the sources. Okay, so the data I have, let me show you, like it is EDN-T2. I'm talking about this data set. It is in CSV file, and here it is pretty big data set. I have this hourly data from 1st of January 1993 to all the way to 31st of December 2017 for 25 years. So it's pretty big data set. So I have to specify this time and date. So here the start time will be John 1st and then 1993, and the unit is basically CFS, cubic feet per second, and the start time is 00. It is from the middle of the night. And then here type is very important. For rainfall, you can specify this instant val, means it is the value for that specific time, right? And if it is gonna be stream flow, hourly stream flow, that means the value should be average over the time period, means per hour. Okay, if it is a rainfall, then it will be like per cum, means cumulative for that 1 hour period. Since it is stream flow, we take average over that time period, so it is per hour. So this is very important. And then what do we have to do? Since it is manual entry, we have to entry here manually. Not manually means one by one. You can do that if you have time, but here we have very long list. You can copy both column, or you can copy only this data column. It doesn't matter. Okay, so I'm copying this one, and automatically it will populate the entire thing. So I'm starting from this, and after clicking there, if you click paste, automatically it will start pasting, but it is gonna take a while because we have like more than several, like 200,000 point. Okay, these points are as time series, so it will create the time series on the left side, and then it will even mess with those data set I just pasted. So we have to wait, and then what will do, it will give you entire list as table, and we can plot that. And if it is necessary to even edit any data, if you think, okay, I have some mistake there, I have some error there, you can even easily just edit that, either looking at the plot graphically, you can edit that, or you can edit manually as well from tabular format. So you have all these options, and once it's done, so this is manual entry, and next we'll even enter other data set as well. So the benefit of using this .dss file, it is called data storage system. So this path name A, B, C, D, E, F, so this path name is very useful. So when we'll call this data set, this time series, then we will use this path name. So if you use any HEC-HMS model, HEC-RAS, HEC-ResSim, and any other model, then you can call this path, and it is automatically give you this plot. So we are done with the CFA plot. It is gonna give you the plot of the data set. See, it's the stream flow. Here you can see it is CFS, and it is up to 2017. It is gonna give you only from 19 this date. Okay, so what we have to do, even we can, so I'm gonna give you the plot option here, how to even export, then you can learn. So here, if you have this plot, see, it is not looking good, right? What I have to do, I have to even specify the title, I have to specify this axis, and I can modify everything. Even I can rename this one. So how can you do that? Even you can click on file, you can save it if you are satisfied with this plot. If you are not, then even you can see here legend. For example, this is the legend, right? This is for this one, EDN-T2, and it is NWM simulated time series. So legend placement, if you're not satisfied with that, you can even put it on the right panel. Okay, you can put it on some other places, you know. Okay, right panel, and you can put it in separate window, and you can put it like upper left, upper right. So find the empty space. That is the empty space, right? So we can put it there. File, okay, view, and left. Okay, upper, left, so it is going to be here. But if you want to even provide title, then it is not going to help you. Okay, so the best way to put, you can put it like on the right side. Okay, then we can give the title. Let's do that property. Okay, plot properties, and then it's gonna open this, and let's see at the same time what changes we can make. And here, right, if you want to even draw the grid line, it's there. If you want to remove it, you can change the color, you can change the weight of the color, and you can fill it, you can point, you can even draw point, and then you can apply. It's going to give you the point, but you can't see that, right? So that's why it's better to avoid. If you want to even show the missing data, you can do that. Even if you want to even interpolate, you can also do that. And then what you have to do, if you go to viewpoint, then here you can see the options, right? The title, it doesn't have any title, and if you write the title here, so it's gonna give you this. So time series, stream flow time series. Okay, stream flow time series for what? Stream flow time series at that station, right? EDN T2. So I can give this, and then you can change the color, and you can make it bigger if you want, and you can apply, and it will be there. Okay, so it's there. You can make it even bigger, and you can even change the position from center to left and right, whatever it is. Okay, and even if you want to draw a border, you can do that this way. So if you want to remove it, you can do that as well. And then if you want to remove something or add, but for x-axis you don't have any option to add the title, because we know it is a time scale, right? It's a time axis. But for y-axis, what you can do, you can add a label. This is the stream flow or the flow, right? Stream flow, and you can write even the CFS as well. And similarly, you can use bold, you can increase, and whatever you want to do, you can do. You can add even border as well. And then tick mark, even you can add minor tick, you can add, see, this is the minor tick, even you can manipulate other stuff as well. And for legend, okay, you can even draw the legend title if you want here, which one is which. You can do many things there. And for layout, you can check, and after finishing all this thing, if you are satisfied, then it looks good, right? Yeah, streamflow, and it looks good. So what do you have to do? Even if you want to see the data, you can see the tabular format. You see time and then CFS and what is the value and unit, everything is here. And if you want to even save it, you can print it, then you can save this as what? As PNG file or WMF or JPEG or PNG. I like PNG, so I'm gonna save it where? Anywhere, right? And I can save it here by the name of what? This EDN T2, and that is gonna be like PNG. So I'm gonna save. Maybe it's already saved. Let's check if we can see that. Okay, let me open that downloads, and maybe this time we can see it's there. See, it's there. It's kind of publication quality. See, you can clearly see that it looks good. And even you can use this for reporting purpose. Okay, so this is one way to generate or enter dataset into the DSS file. Okay, so if you are done, then save it. Okay, it's asking if you want to add more, then return to this screen, or I'm gonna click no. If I need to, then I'll go back again, no problem. So I have this. Even you can click there, you can even plot it. Okay, there, it's there. Okay, so you're done with this. And now what do we have to do? We have to add another data set. This is for only 1 point. Okay, this is for only 1 point, but it is gonna give you only yearly basis. You can see it is gonna give you yearly basis, monthly basis, it depends on the hour. Okay, so what next? Data entry. This time I'll enter that manual, okay, pair data. Pair data means is stage and discharge. Okay, before doing that, okay, let's finish it here. Then we can go for time series and automatic thing. So here, see, the path is a little bit different. So I have a pair data. Let me close this one, and then I'm gonna open a paired data set I have here as a Excel file, this one, okay? This is another station within that Matagorda watershed, and then it is like stage and discharge, basically the rating curve. So what I have to do, I have to copy the stage and the discharge. Since it is a manual process, so even for stage and discharge or paired data, there is no way to import automatically. So this is the manual process. Again, I'm gonna give like paired, okay, paired, that's okay. And here I'm gonna give the name of the station at 081640000, and this is gonna be, see, if you click there, it's gonna give you X independent parameter. So this is gonna be your X-axis. So this is the discharge. So this will be like Q, and that is the dependent variable stage discharge. We can call it SQ curve. That's why S will be along the Y-axis, and the D part will be, this is observed, okay, this is observed USGS. So observed data, this is basically elevation data, height of water, and then this is from USGS. So easily you can understand that this is paired data for this location, and it is observed, right? Observed elevation data, and it is from USGS, the source. And here we have one number of curve 1. If you increase, your data will be divided. And here we can see the horizontal axis will be X. That means along the X-axis we'll use the independent variable Q, the flow rate. Here the X unit will be CFS, Y unit will be fit for this case, the data I have downloaded, and X type linear, Y type linear. The same way here the level and the unit for X parameter, what will be the unit for X parameter is CFS, and the type is what? X parameter is the flow, right? And the unit for Y parameter is feet, and the type is basically elevation. Here it is. Now I have to copy and I have to paste one by one. So I'll copy the first stage, not stage the discharge, because that is the independent variable. So I'm gonna copy that and I'm gonna paste it here similar way. Put your cursor there and paste. And after that, I'll copy another one, the stage, and I'll put it on the other side. And then I'll plot it. It'll look like a rating curve. So we are done with this, okay? So let's go to stage and copy the time series and open it, and then put your cursor there and paste it. Once it is done, we can plot and we can see it will be automatically added to the previous DSS file. So we are adding a time series and we are adding a pair data. If you have constant data, you can add that. So that is the benefit of using this .dss file. You can even store different types of varieties data set, and even you can use that. So it is missing here 1.25. I'm gonna fill this up, and then if it is okay, I can plot it, and let's see based on the data set, because it is observed data and 15-minute interval. So that is the rating curve I have for this data set. So what we have to do for adding that to the previous data set, I have to press save. It is also asking the same thing. I don't want to add anymore, so click no. This, okay, window is gone. So we have this here, and let's see where it is. So let's find that. So last one, see the pair data, it has only one, and SQ, observed, elevation, USGS. I can plot it from here as well, and you can even change the plot as before, and we can export it. Okay, so this is how we just added manually two time series, one time series and one like pair data. I can even enter now the same time series or different time series that is basically in CSV format. Then I'll also import it as Excel format, as text format. Okay, so now even I have the same format, the CSV format. I'm gonna import that. So time series, import time series data, and here from here I'm gonna import this one, MTP T2, okay, and open. It is gonna give you this option, and you can see that the first column, this column is the date time, that column is the flow. But here if you just entirely try to import, but it won't work because you have the text here, right? Text data. So what you have to do, you have to ignore this, right click and skip this cell, and right click and then skip this cell, and then here right click and specify that okay, this is my date time, right click and date time column and date time. So automatically it will understand, okay, this is my date time column, and then right click here and then right click and then specify that okay, this is my data column. So whatever the data you have, it is gonna give you this option. Then you have to specify again that okay, it is also Matagorda, it is also Matagorda watershed, and this time the name is MTP T2, the name of the station based on SHEF chef ID, and here it's gonna be simulated, right? Simulated as before. And then we have this data set is also from National Water Model, and see automatically this time it's been populated with this. Why it is giving you this 31st of December 1992? Because the beginning date there it is 00. So since it is 1st of January 1993 and this middle of the night, it basically the same time, 31st of December 1992 and the 24 hour. So this is how it starts, and the unit you have to specify the unit CFS, and here it is not instant val, it is also per effort. If you just click here import now, it is going to import the data set. Okay, it's done, and again it is asking you close or return, so I'm asking to close. It's done. So let's check EDN. We entered it manually and we have the pair data before that in between these two, right? But automatically it arranged. So now we have this MTP-T2 and the plot looks like this one. You can zoom in, you can see this is stream flow, you have CFS and the time. Okay, so this is how we can even import time series other than just manual entry, right? Copy and paste. So other than CSV file, let me show you. If you have, right, we just imported this type of data set from CSV. From this CSV we have date time and this flow. If you don't have this data, if your data set is like Excel, so here SBM-T2, it is like Excel S. So here you have the same thing, but the format is not CSV. You don't need to even convert. So how can you even import this one? Okay, this is SBM-T2, and here it is. You have to go to data entry, import, instead of time series data, go to Excel. Okay, and then see it is specifying that okay, this is the SBM-T2, and then open it. It is going to open and it will give you the same option to select. Here and you can see the same thing, date time here. So what you have to do, skip this cell, otherwise it won't understand, and it will, because this is based on JavaScript, so it will create problem. So click here, right click, date time column, specify this is my date time, and click there at the top and then specify this is my data column. So it is gonna understand that okay, this is my data, and again it is asking okay, Matagorda, and the name of the station will be SBM-T2, and it is also simulated. The only, see here we have to select 1 hour, and it is basically from National Water Model. Automatically it got the starting time, this is CFS, and it has to be per effort. Import now, and import, it's gonna import. Okay, it's imported. I think it's already done. See here, close. So let's see SBM-T2, this one, and we can plot it. We can see the similar plot. Okay, you can zoom in and you can see, and if you want to even export it, you can change the plot and you can export as well. It doesn't matter. So what we have done so far, we entered this data manually. We entered the manual pair data, and we also imported this time series from CSV file, and we also imported the time series using Excel file. So other than this, if you have a text file, okay, .txt, let me show you the file first, then I'm gonna import. So here I have the text file, but it is not in that order, okay? It has many columns. Right here you have the agency ID, USGS, you have the site number, you have date time, and then you have time zone, you have like the time type, CDT, central date time, and then you have the value of your stream flow, right? So from this type of data set or text file, how can you add those? So go to data entry, you can even manually do that, but I'm not talking about manual thing. So import, and then again you can use time series, okay? And then here you can see it is gonna give you all these options. Select this one. The only way to import it, to specify the date time column. We don't need this, we don't need this, we only need this column, and we need that column, okay? So we have to exclude this, means skip cell, we have to skip this cell, and we have to specify, okay, this is my date time column, and it will be colored, and then this is my data column, then it is going to give you this. So we know the ID 08162600, and this is observation data, so I'm gonna give the name as Matagorda as well, and here it's gonna be the name of the station always I'm gonna give this 08162600, and it's either simulated or observed. It is observed, so I'm gonna give, and then the time interval is 15 minutes. You can see you have to select it is 15 minutes, otherwise it will be erroneous. And here it is USGS, the source is this, and see the data is starting from this date and this time, automatically it got it. So it is also CFS, and it is not instant val, it is forever. And if you import meow and import it, it's gonna give you the same option when it's done. So the ID is 08162600. So this is from text file. It's somewhat similar, but you have to follow this sequential order. And after this, what we'll do, we will even directly, other than importing or exporting to your local drive, what we will do, for example, we wanna, because if you have like observation data, so you download it from different sources. Most of the time within USA, we download this data set from USGS, United States Geological Survey. So they have this data entry. Okay, so it is showing some error, but it doesn't matter because it has one error there, but still it's good, it's imported this data. So here is the data set, you can see observed and USGS, and we can plot it. Okay, we can plot it because this data is not covering from 1995. That's why it is starting from this time, 2007. That's why we got the error, but it doesn't matter. So that's why it is the benefit. You don't need to have the same time range. Anytime a range, you can even import and make a single data set. But when you will use this data for specific model, you can even use a specific path to call the specific data set. So that is the benefit of using this .dss file. So we are done with this one, and if I close it, so this is basically a .dss file, means simulated, and I'm gonna close it. And what I'll do, I'll open another data set and I'll create a new data set, because I have to show you if we have different data sets, how can we make one? So that is my idea. That's why I closed that, and here instead of simulated, I'm gonna create another one by the name of observed. Okay, and this time instead of adding from a local drive, I'll just download it directly. Okay, so I'm creating new dataset .dss, and then data entry, import, instead of importing manually or from any text file or from any dataset, I'll do USGS wave, If you click on that, it's gonna give you this option. Select the data type, either daily or instantaneous, 15-minute or hourly. I can select this 15-minute, okay? Or you can select this annual peak, real time. So I'm gonna select this 15-minute, and the start time is 1993 to 31st of December 2017. It's there, and you can even select the UTC time or the local time. But for USGS, yeah, it's convenient to download the local time because most of the model they run as local time. So you can do that. And here, either we have to provide the ID, or you can even download the ID by state name. So here, get the USGS station by state. So for Texas, I can select Texas, and if I click OK, it will list all the stations within Texas. We have 1085 gauge location, and if I know the ID number, because I know all these IDs, right? So these are like 08162600, and other IDs I have 08164000. I know this, right? And 08164300, 08164600, and 08164800. So 081626, we have to go, okay, 16 here, it should be 26, this one, okay? So select this one. I'm gonna download this 26 35 400, the other one 43. These are the, and you know the name of the river, Navidad, Lavaca, okay? And then you have 46, and 48. So these are the stations, okay? These are the stations I can download, and automatically it will download, okay? You can see I selected the stations from the list. At first you can download the list of the station by state, and then if you just click import to DSS, it is gonna take a while because it is retrieving the data set. Because calling, because I have written a script in Python that can even do the same thing, because it is not that rocket science. It is pretty simple. If you have the link, and if you have the link of the storage, whether they stored, so they store all this data set there. So basically the format I can give you here, if you give the name USGS 08162600, so it is gonna give you this. See here it is, name and everything. And if you just specify your date time, like from 1993, okay, from 1993 1st of January to today's date, no problem. So if you just want to plot, you can plot it, or if you just want to okay, you can plot it. It is just opening because it's loading, it takes time. So here, see, at the same time it's even loading for ease of downloading. So always it takes time. You can see the plot. If you see you have data, then you can even download the tab separated. So this is the link here, national, okay, NWIS. So from this website, if you know the link and everything, you can write a Python script that can automatically download this data set. So I already demonstrated this one in my previous videos. That is there in the data download playlist. And see, at the same time I'm downloading using this portal and using this browser, and the data set is pretty big, that's why it is taking a while. So this is the way you can even display. Let's see, by this time still it's going on. One is done, another, see, this reading the station 08164000, it's reading now, and at the same time it is even loading from this side. It's, yeah, see, it's done connecting to the wave. Maybe it's connecting now 43, and then it will download that data set as well. And even you can plot, you can process, and the reason I'm trying to show you, because this data set has a description, and you have to even write the script in a way because it has a text description. So you have to even avoid all those rows or the lines of the text file, and then we have to just export only the date time and the data set you need. So this is how they even wrote the same script, same type of script, and it is doing the same thing. It is gonna give you the time and the data, only the time series it is exporting. See, saving the database, and then I think we have a few station, one more or two stations to download. Then we'll have this .dss file. This is basically based on observation, and we already prepared the other one, right, by manual entry and by importing a text file, Excel file, and CSV file. So that is basically simulated. And if I want to make one single file, I can even do that. See, and I'll do that. So I can even merge them together. So you don't need to carry two files. You can carry one file, and your description will be different. So easily, whatever you want, you can call that path and you can import into your model. And see, you can see the plot. Maybe there it is taking time. I don't see here. You can see the plot. This is basically the discharge cubic feet per second, and this is time. And if I use tab separated, so that is the data we need. If I click go, see, that is the description I talked about. It is going to give you the description, where it is located, what type of data it has, and other. See, the file format and everything is there. Then it is going to give you this data after this, and it's going to give you this ID, USGS ID, and the location of the river, Tres Palacios River near Midfield, okay, Texas. So that is the name of the river and the location, the description it's giving. Okay, and the same description you can find it here, 26. Okay, it is the 26 data, 26. This one, see, Tres Palacios River, Midfield, Texas. It is the same data set I'm downloading and showing here. It's already done here. I think we can see 6 station out of 6 it's retrieved. So what do you have to do? See, it's gonna give you the same data set. See, time, and then USGS. This is the name of the station. So basically the same thing. You need to download, and you have the data here, right? You have the data set here, and you have the date time. Okay, no problem. So what do you have to do? Here we just imported it, right? So you can see already it's there, and now even you can close it. You can see it's there, and if you want to plot it, you can see the plot. You can see the plot, it's there. And if you want to go to another station, because it's pretty big data set, see here you can change it, and it's gonna give you this plot as well. If you want to see, we don't have data from 1993, so the data it has, it is showing here. So we have this data set, we have that data set, and if you want to even make one single data set, we can do that. Okay, let me just close this one. Okay, so I can close, and I'll have the dataset name observe.dss. Okay, I have this, and let me show you the directory where we have these two. So we have observed, we have simulated. Okay, so if I wanna, even since observed is like 90 megabyte and simulated is 4.7, what I'm gonna do, I'm gonna merge or copy the data from simulated to observed. So that's why I want to open this simulated dataset and go to file or go to edit, and then merge copy simulated dataset into. If you click that, it's gonna ask you where. It's gonna give to, right, observed. So I'm gonna merge or copy the dataset from simulated, and I'm gonna put this to observed, and still you'll have that simulated, right? So if I click open, see it's copying everything and file merged. So if you close that, and you see that size changed, right? 92, 93. And then what we have to do, you can see that if you just open it, see, you will have access to that simulated. Previously here we had the flow and the observation and everything, right? But for this one, you can see it will be Matagorda, and then you will see that it's gonna be different. See where it is. Okay, it just arranged based on the alphabet Matagorda. Okay, this is N, and before M we'll find This for Navi.river, M will find M here because that dataset is pretty little dataset. So let me find M just before N. Matagorda, it's gonna be some Lavhaka. Okay, after Lavhaka we can here see this is this dataset we entered USGS, right? We saw that right? And we also have this EDNT2. That's why, to make sure that okay, we merge this together. So now we have only one dataset DSS file, and if you even need to import this dataset into any model, you can do that easily. You can even import that. It's pretty simple. Even if it is a HEC-HMS model, HEC-RAS model, HEC-ResSim, or any other model ACC that supports .dss file. So this is one way, and let me show you if there is anything else I can show you. And if you wanna even export it, you can do that. You can even click on this Excel tabulate, and then you can do that. Sometimes if the dataset is so big, it won't open, right? So what you have to do, you have to even make the tabulate. You can even plot it, and you know the table, right? If you plot it, and then if you wanna view, if you wanna go to file and tabulate, you can see the table, and from the table you can even file and you can even export it. Okay, and you can plot, you can export, whatever you can do, because you've already generated this data set. You can plot directly from this, right? So you don't need anything. So these are the options you have. That's why it is pretty useful to know that how to generate a DSS file, and from this DSS file how can I export or import dataset for different model. And the output of these ACC models are also like .dss file. So if you even know how to even read data, how to export data, so you can directly copy that .dss file, and you can even use output of one model into another one. For example, if you run a hard logic model HEC-HMS, and it will give you the stream flow. So if you know how to export or import dataset from DSS file, you can use the output of HEC-HMS, and you can take the DSS file, and you can use that DSS file to use boundary condition in HEC-RAS model. And if you have the HEC-RAS model, and if you have the output of HEC-RAS model, and the output will be also stored in DSS file. And if you run like reservoir model, because a reservoir is a system, I already demonstrated how to set up model for reservoir. There will be inflow from the river, and if you know the inflow from the river, you can easily add that from DSS file. There will be a river network, and if you need to run any rule curve, or if you need to run any condition, you can create that condition as DSS file, and you can directly use that DSS file to run your models to serve your purpose. So that's the general description and the way most people, they use this type of dataset, and you can even explore more how to even yeah, there is another way to calculate. See, if you want to even need what you need, we have like hourly data. Other than hourly data, if I want to even create a data set based on maximum value, maximum yearly value for flat frequency analysis, so you have that calculation function here, even it will give you that option as well. So these are the options we can use in the tools and the functions. You can find it, and then you can directly use this as well. Okay, so that's that. If you have any query or question, you can practice it, and in my other videos, definitely in future videos, I'll show how to use data directly from this one. And this is like point data, time series for any specific point. But in my other videos, I have already demonstrated how to create .dss file as a gridded data set. Because if you run any model, as a gridded model, so your input forcing has to be in that same format as gridded format. So DSS is also capable of generating a gridded dataset. So I already demonstrated in my previous videos that how to generate .dss file for precipitation from XMRG rainfall dataset. So either way, you can create this and you can utilize the benefit of this dataset, which is very effective. So that's that. You can practice and let me know if you have faced any difficulties, and then I'll try to answer and try to solve it. So thank you for watching this video, and thank you for supporting my YouTube channel. Stay safe and take care.